logistics. So let me introduce you Martin, who's the author of Restangular. And he tells me that he's prepared to make lots of fun of Angular resource. So I'm curious what kind of jokes you'll be making.
So, as he said, my name is Martin Gontovnikas, and today I'll be presenting a little bit about how to consume APIs with Restangular. So basically, I'll be doing self-promotion. So, I am a software developer from Buenos Aires, Argentina. And right now, I'm currently employed by Acquicor, which is a DC-based startup. And I just make stuff happen. I work front-end, back-end, and a little bit of everything. So this talk is about learning Restangular and how to consume REST APIs. We'll also see a little bit about $resource and how to use it. So let's start with it. Let's create our first web app with AngularJS. Here we have our input type text. We have our regular ng model person. And then in the span, we are using binding to show the person. So if I type here, Gonto, wow, hello, Gonto. So guys, I'm sorry to tell you, this is not really an app where everybody shows tutorials for AngularJS, because you have no real data, you don't have any information, and you also don't have any centralized point to access it. Every user will have different information, and we always want all users to see centralized information. So look, it's SOAP. No, it's remoting. No, it's RESTman. So AngularJS is a pretty cool library, and they have made $resource, so it must be pretty cool as well. So let's start using it. The first thing we're going to do is to fetch an user. For that, we're going to use the $resource service, and we're going to create a type with it, and we're going to assign it to the URL /API/version1, which is the version of the API we have right now, /users/its ID. So we create that object and we assign it to user, and later we will use that object to call the get method with the user ID 123, so as to get it. That this will perform the request, the get request to the server. And then the second parameter of this function is a callback, which is the success callback that will return the user. Inside there, we just change the name, and then we call $save, which will actually do a put to the /API v1 users 123 with the new information. So now we have our user, and now we want to get all the cars of that user. So what do? We have to, again, create another $resource object, and we have to put here the whole URL again. It's a nested RESTful resource, so we need to do /users, the user ID, /cars, the car ID. We create it. In this case, we're hard-coding the user ID to 123 because we're going to use that. We can also send that later in the function. And here we called the query. This query has also a parameter, which is the success callback. And inside there, we get the first car, we change the name, and then again, we call the $save, which will do the put. Basically, this is how we are using $resource from AngularJS now. So why is this not so cool? First, we need to create one $resource per entity. So that's a lot of work if we have a lot of entities, and we don't want to do a lot of work. We want the magic to happen, like with AngularJS. Also, it doesn't handle relationship between data. Every time we get data or information from our server, we want it to be connected to our resources, to other resources, or to get connected to other information. We cannot do that with $resource. We must do that manually. Also, it doesn't handle nested RESTful resources. There are a lot of frameworks right now, like Rails and others, which handle nested RESTful resources as some resource may have a parent. $resource doesn't handle that automatically either, and we need to do that manually. Also, there's a lot of growing knowledge about hypermedia right now, and there's right now a lot of people starting to use hypermedia. The basic idea is that you have just one URL to the server, which is the point of entry, and then the server will return to us all the resources, which will have a link to themselves, a link to their parents, and a link to everything. and we are going to use those links to fetch all the information from the server. With $resource, we can't do that, but we can use that with Restangular. So in that case, we will only use one URL. Also, we can't add configurations per resource aggregation. What does this mean? With $resource, we can create configuration with either all of the resources or just one. But what if we want some configurations for 3, another for other 3 of them? We can't do that right now. So this is not cool. So this is the Restangular signal. I'm Restangular. So now let's do the same thing, but with Restangular. The first thing we're going to do is to configure the base URL. All of our API is API version 1. So why do we need to write it every time if we can just set the base URL? That is what we're doing here. Then we want to fetch the user. So we have a Restangular method called one, which will create a proxy to do this get. And in here, we are saying the resource name is user, and its ID is 123. So by default, the main way of getting an object is /user/123, which will do the get. Then here we're calling the get method, and here we're not receiving any function success callback parameter, but because we're actually using promises. $resource has added this in the later times with $promise property, but I don't like how it's implemented. I think it should be completely promise-based. So in here, what we're doing is we're assigning the user to the scope, again, changing the name, pretty similar, and then doing the put to the correct URL. Now, this is where the interesting part comes. Now we want to get the cars of that user. So we want to get a relationship from that user, which is actually a nested RESTful resource. So instead of creating the URL again, we should ask the user, hey, give me your cars, because he's the owner of those cars. So in this case, what we are doing is calling to the user the get list of cars. Restangular knows the user URL, which is /users/123, as that's the resource name and its ID. And then when we get the list of cars, it just adds /cars. This will return a promise again, and inside there, we will receive the cars. We can get again the first car, change the name, do a put. Also, if we want to these cars, we can add a new car. If we do cars.post, it will add a new car, but only to the cars of that user. So it will be a post to /users/123/cars. So this means that we can navigate our hierarchies with all and one, which are the proxy generators of Restangular. So for example, if we want to get just a car of all the collection of users, we say all users, meaning RESTful collection of users. From there, get an element, car123, and do a get. There are some times where the name of the resource isn't actually the URL. In those cases, we can call all URL instead of all, in which the second parameter will be the URL of that resource. That URL can be either absolute, as in this example, or it can be a relative path as well. And this is basically how we can create proxy objects from Restangular. But all of this, all, one, get list, all of those methods will be added by Restangular on your promise. So on your success callback, they will be already added. So as I was saying before, what if the element has a link to itself? In that case, we don't need to change any of our code. We just need to add a new configuration. What we are doing here is setting a new Restangular field, and we are setting here the path to get that href. So if every entity responded by the server will have an object called self, and inside there will be a property named href with a string that will represent the URL to that element, we can use that. As you can see in the example later, we are getting the list of all the users, and then we're calling the remove on one of those users. As that user has the self href property, and it has the absolute URL, example.com/users/gonto, that will be the URL used. It also supports relative. So if your href is a relative URL, it will be taken into account with the current URL. And if an object returned by the server doesn't have this property, it will fall back to the default Restangular behavior, which is using the ID of the element and the name of the resource. So another thing that is important is once I receive a user, a card, or whatever, I want to be able to add new methods, new properties to that and to those entities, because we want to interact with it and we want to give it behavior. So for that, Restangular has two hooks. It's add element transformer or extend model, which is actually a shortcut. Add element transformer, in there, we just say, hey, whenever you receive a resource of the type users, call this callback function. The second parameter, which is a false, means I just want to modify elements. If you set it to true, it means I just want to modify collections of users instead of just one user. And if you just don't put anything, it will be called for everything. And in there, you will receive a user, and it's a regular JavaScript objects as all models in AngularJS. So you can add the property you want, a function or whatever. But Restangular has also a helper function, which is called add Restangular method, which will add a new method to that entity that will do an HTTP request the way you want. In this example, we're saying, hey, add a new method called ping, which will actually do a post to the do ping path, and do it with the headers XApp example. So later in the example, you will see that we are doing users sub0.ping. That will actually do the query that we have said before. If we had put there user.name equals Gonto, we could then ask a user, which is the username, and it would return Gonto. As you can see, it is after you have configured it, you don't know that it's been added. It's transparent to you because you will receive in the promise a list of users, and every element of that list of users will have this extra method that you have defined in the configuration. So what other configurations does Restangular have? Restangular actually has like 20 or 25 configurations. You can see them all in the GitHub page, but some examples of it are first, what if your ID of every element isn't the ID field, which is like the most common? You can set the path to the ID. For example, if you're using Mongo Labs, your ID will look something like this with underscore ID, and you can use it anyway. Also, you can set request interceptor so that it will be called before every request. Response interceptor, which will be called after every response, and error interceptor. With that, you could create, for example, a global loading. So before every request, you start the loading, and then if there's a response or an error, you stop the loading. Those are just examples. You can see all of them in Restangular's GitHub page. Another thing that I was telling you about is that we can create scoped configurations. What does this mean? That with Restangular, we can actually build a new Restangular service with some configurations that we want. So let's assume that our common Restangular doesn't add any header, but we want our bond Restangular to always add a header, which is xout James Bond. In that case, we call the with_config method. That method will receive a configurer by a parameter, and that configurer will have all the same configurations as the Restangular provider. So there you will be able to configure anything. That will return a new Restangular object that then you can use to query anything, and all those configurations that you have created will be used. Most of the time, this feature is used with custom services in AngularJS. So for example, a lot of people create a comments service, which will be used for comments resources. And in there, they add the headers that they are needed, the request params, and all of those will be used for that comments resource, for example, and all its nested resources. Well, another important thing is that it uses etag by default. So if your web server supports etag, we will be sending the if not match, the last modified, and we will be using it. If your server doesn't support etag, you just don't care about this slide. It's entirely based on promises. So it's really promise-based, which is the way that it should be used. It supports all HTTP methods. It means it has options, it has headers, it has patch. Currently, it's every time more important to use patch because with real-time applications, we want to send changes. Restangular supports that by default, and $resource doesn't. Also, you can run your custom operations. So if you want to do a put or a post to not like a regular URL for putting, if you want to do a put instead of to the elements to another path, you can do it by calling custom put, custom post, and in there you can just customize the object, the request parameters, the headers, or whatever you want, and more stuff. You can check it out at github.com/mgonto/restangular. Mgonto is also my Twitter handle if you want to add me. So this was the presentation to learn about Restangular. Thank you for listening, or at least pretending to. It says question will be after Jeff Cross presentation, so this slide doesn't exist. Thank you, everybody.
Thank you for this presentation. It's very interesting take on how to do RESTful URLs. I like it. There's a lot for us to a lot of cool ideas in there that I really enjoyed. So now Jeff, he's going to present another way of talking to the server, which is Realtime API.
Thank you, Mishka. There we go. Hello, I'm Jeff. Can you hear me okay? Okay. I work on the Angular team at Google. I am presenting on something called OmniBinder at the moment, but this name has changed quite a few times, and it will probably change again. And so when Martin wanted to present tonight, I thought it'd be a good opportunity to talk a little bit about this new framework I've been working on top of Angular and the problem it's solving. So the high-level goal is to be able to bind Angular models to anything, particularly anything outside of the Angular app itself. So why a new framework? Remote data binding should be as easy as in-memory data binding when working with an Angular application. It's not easy to do this with, it's easy to do this in an app where you just have local data that's in memory or even in client-side storage where you're the only user using it at the time that you're using an app. It's not as easy when you have distributed data that is being used by multiple people, changed by multiple people in different client applications at the same time. There should be a first-class API which services third-party APIs and others could implement and work with in Angular that makes it easier for them to make bindings. So like Firebase, they've made their Angular Fire library, and they had to do a lot of work to make that work. But they've actually been helping on developing this new framework that does a lot of the heavy lifting of the hard things inside of Angular. An app developer should only have to know one library to bind to these various protocols. So I shouldn't have to learn, if I wanted to integrate with the Google API, for example, I shouldn't have to learn their Angular framework that they've developed from scratch to know how I need to prepare my models for it. I just want to understand in one place how I can bind to different protocols and then drop in their protocol underneath to be able to persist and update my data. So what is OmniBinder? It's a real-time micro framework on top of Angular. It makes it simple to bind Angular models to any supported backend. And it automatically synchronizes data between client and data store. So typically the data store will be some external data service, but it does not preclude local storage or other types of client-based storage. And it's a collaborative effort with members from Angular, Firebase, StrongLoop, and some other teams. So I want to show a little bit of a demo of the working version of it now, and then talk a little bit more about what's happening underneath. So I'm using Deployed, which is a framework that myself and Richie Martori over there worked on, and it makes it easy to build APIs. And so I have an API that's powering this that has a collection of to-dos. And in this application, I just want to create to-dos, check them off, and get rid of them. So I'm going to open the same Angular app side by side. And then you see if I create a to-do here, it creates it on the other screen. And if I create one here, it also goes to the other side. And these are ordered alphabetically. So if I check one off here, it also checks off on the other side. And the same if I uncheck it. And if I check this and then archive it, it'll delete this and delete it in both views. So all this was accomplished with just a little bit of code using the OmniBinder framework. So here is where the magic part is, and I'll show you a little bit of a closer view of this in my presentation. So in my controller, I had a deployed protocol ready to go, and a protocol is something that works underneath the OmniBinder library to handle the low-level data synchronization to a service. But in my controller, all I had to do was create a binder instance using an OB binder factory, which takes a scope, a model name, a protocol, and some options. So here I have an option which is key ID, which says inside of my collection, the unique key is called ID. So OmniBinder uses this to ensure some operations are safe, that it's updating the right object rather than relying on position within a collection. And this type says what type of model it is. So I can be explicit about this should be a collection. And this query is something that my protocol asks for. And here, the deployed protocol just wants to know what the collection is called, so it can perform all the operations after this. And here's a diagram of how it's actually working without showing all the parts that are making it work. I have changes that come from my scope and my model, my model on my scope, and those go to the binder, which then kicks off a change pipeline during which I, as a developer, can intercept changes before they go to the protocol. And then the deploy protocol handles the business underneath that applies the changes to my database. And the process kicks off the other direction when I have a change inside of deployed. It goes to the binder, which then kicks off a change pipeline to the scope, where the changes are applied to my local model. So what are the goals of OmniBinder? So the goal is provide a contract between protocols and Angular models. And I'll show a little bit about what that contract looks like in a moment, but also to solve common problems associated with syncing, like recursive updating. If you've built a real-time framework with Angular or anything, you know that if you just try to bind something without intercepting changes from a model to a protocol, you're probably going to get an update from the protocol after you've just updated something saying, okay, you've created this resource. Oh, here's a new resource that was created. And then you have to determine, was this the same resource I just created, or is this some other resource that my protocol is giving me? And then you apply that to model, and your model will fire off a change and say, oh, something's changed here. We try to remove that problem inside the framework so you don't have to think about it. Representing subsets of large collections of remote data. So working with 1 million rows of data on a remote database without having to load 1 million rows into memory, which doesn't work very well. That's a problem. We want to make it as seamless as possible to act as if you're manipulating the entire collection locally. Throttling and batching updates, so conserving network activity. If you're making if you're binding to a key up event on a model, for example, you may not want to send every event to the protocol. You may want to wait for 250 milliseconds or so to send all those changes at once, so you can be sure you're not overwhelming your network. So what is it doing to accomplish these goals? So one, we've implemented object observe style change sets in the pipeline. So if you're not familiar with object observe, browsers are starting to implement these APIs. They're working out a standard on how to watch changes on objects and arrays and respond to those updates, which is driven very much by how Angular works, because we have the ability to watch objects and then respond to those changes. But now there's native functionality that's rolling out in browsers that when an object changes, you can see what type of change it was, where the change occurred, and what the old value was, so you can do something with it. So in OmniBinder, we subscribe to this, and we say when a model is updated, we want to package that change to the model in an object observe or array.observe fashion and send that to the protocol in the same way, so that it can just persist that looking at this change. Second is that we're implementing a simple contract for protocols to implement. There are really just two methods a protocol needs to provide. So I can create a service for my protocol in Angular, and I just have this process changes and a subscribe method. And process changes looks at changes on this delta object, which are those object observe or array observe changes, and then determines how to apply those to my collection on the database or wherever it's being stored. And then there's a subscribe method that says, take my binder, look at my query, and then figure out how to subscribe to changes on the server and notify me when things change. So under the covers, there are some other things going on. There's an OB observer service that uses object observe and array.observe to watch arrays and their child objects. Again, as a developer, you don't need to see this, but this is something that's doing the heavy lifting. And OmniBinder observes both directions to syndicate changes to the model or protocol. And it treats both directions pretty similarly. And Model Writer is a service that is the equivalent of a protocol, which applies changes from a protocol to a local model. So the third or fourth thing here is this change pipeline. And so this is a concept that you can implement a protocol that is on the other side of a model that can accept changes that come to it. And if you want to, you can just let the binder do all this work for you and say, just figure out the changes, give it to the protocol, and let the protocol persist it however it wants to. But there are cases where you want to apply some other behavior or process changes before they get to the protocol. And so there's this change pipeline concept, which I've implemented and am reworking now. But essentially how it works is when a change comes from the model, the OmniBinder registers that change and kicks off a change pipeline to the protocol. And in that pipeline, I can implement a series of middlewares with a signature like the one I have here, binder delta next, where I can do whatever I want to look at the delta. I can stop the delta or wait for a while to continue processing it. I could add a unique change ID to this delta so I can store that for analyzing later. Or I could do whatever I want, and then it eventually gets sent to the protocol. So a protocol could say they don't want you to use the change pipeline, but you have the ability to use it as a developer. And another example is you may want to batch changes, like I mentioned earlier, from a protocol or from a model so that you can package them together instead of applying everything one by one. And this is better documented on the GitHub project, which is linked to in the slides, and I'll share another link at the end. So the current state, it's a working prototype. I'm starting to spend more time on it, and I've been working with some other folks on making it good. But it is a prototype right now. I wouldn't throw it in a production app just yet. And the focus right now has been binding arrays of objects, which I think is the most common use case for data in applications. It requires object observe enabled, but this will be polyfilled. So you'll have to enable this in your flags in Chrome, enable experimental JavaScript to see this work. The design doc is on GitHub. In the README, there are some goals for the project and problems it's trying to solve. And what's next? So we're starting to use it with some real-world applications and see what are some things missing from it, particularly in the design. What are some flaws with the design? What does it not let you do, or what does it make difficult? And what could be done to make it easier? The change pipeline implementation is being re-implemented. More protocols supported. So Firebase is one of the initial protocols. We're working on the Angular Fire library to work underneath this and also deployed, but I'm interested in adding more API services and data services underneath it. Supporting more types of data, so rather than just arrays. And implementing object observe more deeply in Angular, which is an ongoing effort to start to replace some of the work that we're doing with Watch right now, starting to use object observe to do that instead. And last is standardizing a protocol for real-time web apps. So this is another collaborative effort that there's a good document on the GitHub project with some thoughts from myself and a few others involved with this called Stretch Protocol that I'd recommend taking a look at. But most of all, I could use help. If you like to live dangerously, I would say grab the project, create a protocol, play with it, read the docs and see what you think about the design approaches, and submit issues or pull requests on the GitHub project. And I'd love to hear what you think. So thank you. And this is the URL to the project. Do we have microphones?
When you get update
We have to do it for the live stream.
when you get updation from your database, is it relevant to records you have checked out or to the database as a whole? How do you focus update messages so that you're not receiving a fire hose from everything happening within your database?
So that's up to the protocol to implement that under the covers. On the client side and the server. The server needs to know how to interpret it. But the place you would specify that when creating
scope $scope.user.get, and that will actually return a promise, and you add the then. But in the future, you can do again $scope.user.get, and that will return a new promise with a new get. So you can do whatever you want.
Okay, so what I'm trying to understand is, does it send a single get, or would it send two to the server?
It depends on the browser
Oh,
right now. For example, Chrome, when you do like 3 gets almost instantaneously, it knows that you're doing 3, so it's just going to do 1 and return a cached response for the other 2. I think Firefox is implementing that as well, but if you use IE, of course, that doesn't happen.
Okay, all right.
No problem.
So the binder instance has a method called onProtocolChange that you call with the object observe or array observe style changes as the only argument. So it's up to you when you implement the protocol to figure out how do I know when the server's changed. Because
okay, thanks.
Looks like we. Oh, one more question. Yes.
Gentleman in the blue shirt. I was pointing at you, Mishka.
What? I think one more question over here, and then I think that we will wrap it up. And afterwards, if somebody wants to make any announcements, we can take those.
Simple question. Do either?
So it'll probably always be its own module.